We're going to go back and touch on the neutralization reaction again. So for a neutralization reaction, the format that you're looking for is an acid plus a base, and that's going to form a salt and a water. In this situation right here, this is a monoprotic acid, which means there is only one acidic hydrogen that's going to be transferred. That acidic hydrogen will be transferred to this hydroxide group on your base to form water, H2O. So there's that part of our product right there. The other thing that we're going to form is a salt. And so that will form between the calcium and the perchlorate ion. So our products here are going to be calcium perchlorate, and that's going to be aqueous, plus water. Now, when you get done with these, it's really important that you make sure that you balance them. This one is already balanced. No, it's not. This one is not balanced. In order for this to be balanced, we'll have to place a coefficient 2 here and a coefficient 2 there. Now we're balanced. Okay, so this is an example of a very simple neutralization reaction, and this is the molecular formula. From this molecular formula, you will be asked to write the complete ionic and the net ionic equations as well. Now, for example number 2, this one's a little bit different because it's diprotic. It has 2 acidic hydrogens that it's going to transfer. Now, what I want to show you is not immediately the end result, but the mechanism that this goes through in order to get the final product. A lot of you in class were wanting to get right away and put the final product as your answer immediately, and that's fine. If you are intuitive enough and you've done this enough that you can have that foresight, if you know what the product's going to be, great. But this is actually a 2-step reaction, and I'm going to show it to you in 2 steps. Okay, so what's going to happen is one of these acidic hydrogens will be transferred to this hydroxide in the base, and that will form water. I'm going to go ahead and put that as my second product. Okay, and then the remaining atoms will come together to form our salt. We have a potassium. Now we have 1 hydrogen because remember, we only transferred 1 hydrogen to get that water. And then we have our SO3. So our salt is going to be KHSO3 aqueous, plus we formed water. Now, I told you this is a 2-step process because this is still an acidic hydrogen that's going to be transferred. Okay, so we still have to worry about that hydrogen. If you have 2 actually have to be transferred. Okay, so the second step here, we will start with our intermediate product, which is this. It will still react with our base, which is that. This acidic hydrogen will be transferred to our hydroxide there to form water. And then what's left over will form our salt. We have 2 potassiums, okay, and we have SO3. And that's going to be aqueous. Now, remember, this hydrogen here formed water, so it's no longer there. That's where we got the K2SO3. Okay. Now, to get your final molecular equation, you have to consider, again, remember, this is intermediate, okay? This is an intermediate thing going on. This is what you started with. This is what you ended with. And so that's going to be your molecular equation. So you rewrite that. and then you look and see if it needs to be balanced, and you balance it. And then that's your molecular equation. Now again, when we were in class the other day, this is where we started with, okay? So we started with this, and then we ended with that, okay? Which is our final equation. But these are the steps to how we got to this. So again, if it's diprotic, it will be 2 steps. If it's triprotic, it takes 3 steps, 3 different times that you're going to transfer 1 hydrogen, 1 at a time, in order to get your final product.